Brian Harris is a co-founder and CEO of MedRhythms, a digital therapeutics company focused on the intersection of music, neuroscience, and technology. He is one of 250 neurologic music therapy fellows in the world, and his clinical work was focused at Spaulding Rehabilitation Hospital in Boston, where he created and implemented their first inpatient full-time neurologic music therapy program, specializing in traumatic brain injury, stroke, and neurologic disease, and built this program to be the most comprehensive NMT program in the country. Brian is also the chair of the Arts and Neurosciences Group at the American Congress of Rehabilitation Medicine. He has given numerous presentations throughout the world at venues including the American Academy of Neurosurgeons, the American Congress of Rehabilitation Medicine, Berklee College of Music, Harvard University, and Google. Brian's work has also been featured in Forbes, CNBC, The Huffington Post, Pitchfork, Mashable, The Boston Herald, Xconomy, MedTech Boston, and on Chronicle Boston. Brian was recently named to MedTech Boston's 40 Under 40 Healthcare Innovators for 2017, and he is also a Big Bang Theory guy.
Well, thank you very much, and thanks for having me. And after hearing these guys speak, I'm even honored to be able to share the stage with you guys, so thanks for the work that you guys are doing. And today I'm going to talk to you about music. And this work that we do at MedRhythms and that I'm trained in is about the power. I don't have a clicker. I got it. It's all about the power of music. Now, is the power of music, the music has power, something that we can agree on? Right? And when we think about what kind of power music has, we know that music has the power to lift us up, to make us feel certain emotions, to give us energy, to help us relax, all of these things. We call that music as a social science, but what we're actually now learning about music is that we can start to shift that paradigm from looking at music from a social science to looking at it purely through the lens of neuroscience. Everything I'm going to tell you today is applicable to 97% of the human population. Regardless of age, culture, ability, or disability, everybody's brain responds the same to music. That music is now, we know, as a hardwired brain language. Now let's talk about music. When we passively listen to music as humans, it activates the parts of our brain that are responsible for movement, for language, attention, memory, emotion. And they've now shown that there's no other stimulus on Earth that engages our brain as globally, simultaneously as music does. That's step one. Step two is that we now know that training in music, so training in music could be actually learning an instrument, or it could be engaging in these interventions that we do as music therapists. And it's now shown that those engagements in music actually aid in the process of neuroplasticity. So your brain's ability to create new connections throughout your entire life or strengthen old connections throughout your life as well. That's the reason why people who have brain injuries can recover, is because of neuroplasticity, the brain's healing properties. So when we think about global activation and neuroplasticity, that gives us a brand new and enormous opportunity to help people in a new and novel way. Number one, what we know is about rhythm. How many people like rhythm? Here. Any dancers out there? Yeah, so what we now know is that when we listen to a rhythm in our environment, it activates our auditory system, but we now know at a neural level that our auditory system and our motor system are combined, and that we can actually use an external rhythm to cue movement. This is a man who has had a stroke, and what you're going to see here is this is the baseline video is after he's had 3 weeks of PT, 5 days a week at the #2 rehab hospital in Boston, being Spaulding. Break. Intervention, 45 minutes later, this is an intervention that I did with him called rhythmic auditory stimulation, and that's the end of session one. So we know that rhythm has this powerful ability to activate the brain, activate the motor system in healthy people, but also people who have damage to the motor system. Parkinson's disease, Huntington's, MS, stroke. We can actually use music as an external cue to cue the damaged motor system or to create pathways around it. Hashtag neuroplasticity. Let's go past this. And actually, this is a DTI reverse colored image of pre and post treatment with music. I'll explain it later. Now we talk about language. So we now, many of you I'm sure have known somebody who's had a stroke perhaps that has had trouble or difficulties with speaking after the stroke. We know that language is primarily a left-sided function. I want you to say this after me. Say, I need the bathroom. So your ability to speak that from an expressive point of view was primarily because of your left hemisphere. Now if you sing, I need the bathroom, the fact that you use rhythm and you use melody in that, or intonation in that, you engage the right hemisphere of your brain. And so what we do is we teach people to speak again through what looks like singing. So rather than saying, I need the bathroom, we sing, I need the bathroom, that engages the undamaged parts of the brain. And what you show here is my favorite neuroanatomy term, which is called the arcuate fasciculus. It's fun, sounds like a dinosaur. The arcuate fasciculus. And this is just pre and post treatment. The arcuate fasciculus connects the parts of your brain that are responsible for comprehension and expression. There's a fiber tract. And what they showed is that intensive singing exercises of somebody who followed a stroke actually showed a fiber tract thickness change in the arcuate fasciculus, hashtag neuroplasticity. So now we look at things like cognition. This is actually an MRI of somebody who is in a vegetative state, left versus right. And what they showed is that neural activation in response to live preferred music was higher than recorded music, white noise, or silence in people in a vegetative state. They also showed higher levels of activation of arousal and awareness and interaction with their environment in response to live preferred music. So we're using music in this way to activate people or to engage people all the way from the lowest functioning states and the earliest ages to people at end of life and everywhere in between. Hashtag neuroplasticity, music at science. Woo! It's almost like, exactly. I've been there, but it's like it's a marathon out here, you know?
I really appreciate you all doing this. I wouldn't. So, are there any questions for Brian before I jump in?
Is there any evidence as to why live music particularly is better than recorded?
Yeah, I get asked that question a lot, actually. And so to my knowledge, there's no specific research that has been done on the interactions of why. But we have some idea about the vibroacoustics of live music that can be felt from an instrument. Also the human interaction as well. Those are two hypotheses. To my knowledge, it hasn't been proven yet. Yes?
What kind of music did you use for the test for the person that had a stroke?
Really great question. The question was, what type of music did we use for the person who had a stroke? So that video that you saw there, what we know about how music engages the brain is more about the elements of music. So we know about how rhythm and harmony and melody impact the brain. And so what we have to have in order to do that type of intervention is a very rhythmic or high beat salient music. In this particular case with that man, he was very close to his stroke. He was only about 2 weeks post-stroke. So what we have to worry about in that situation is overstimulation and giving them too much stimulation where we actually have reverse effects. So in that point, I was literally just playing two different chords back and forth rhythmically. How we see that in the hospital usually, though, is we ask the patients what they like the most, and we use their favorite music. Yeah. Yeah.
Oh, is that me? So I've mostly heard about parietal areas for, say, motor neurons for visual motor kind of emulation. But could this be thought of as kind of an acoustic motor mirror neuron system?
That's a good question.
Yeah, that is a very good question. And I think, it's interesting to look at it sort of a acoustic motor mirror neuron system, because we do actually know that sort of auditory motor connection exists. And even if we think about actual mirror neurons, we do some of these interventions with a human being present, walking opposite backwards in front of them to actually try to engage the visual mirror neuron system as well. So there's a lot at play there. Yes?
We tend to think that a lot of structures in biological systems have an evolutionary advantage. What would have been the advantage to humans evolving the ability to respond to music before music was invented?
Yeah, that's a beautiful question. I mean, it's really interesting too, because we've actually seen through the research that babies in the third trimester have the ability to respond to music. So it's literally one of the first things we gain as human beings. We also know that music is processed through our brainstem. And our brainstem is what controls our heart rate and our respiration rate. So literally, as people have brain damage or neurologic issues that decline over time, it's also one of the last things we lose as human beings is our ability to process music. There's a book called Rhythm, Music, and the Brain by a guy, Dr. Michael Tout, that actually goes into that question of evolutionarily why is this possible and why do humans have this. But one of the sort of hypotheses there as well is that what we now have explained through neuroscience is particularly it's about rhythm. And what we know is that when our brains are engaged in rhythm, that it actually makes our brain processes more efficient because everything fires in synchrony due to a temporal cue. And when when our brain processes fire in synchrony to a temporal cue, it actually makes whatever action we're doing easier. It gives us more endurance because everything's firing more efficiently. So there's something to be said about limiting the amount of work evolutionarily that our brain goes through by using an external cue. Oh, yes. Sorry, I can't see much here. It's good.
Does your brain get activated when you hum a music in your head?
Oh, good question. Does your brain get activated when you hum the music in your head? So what we actually do know about that is that humming music, or this sort of mental simulation of music, has some impact on just what we call neural activation. So we would hear that. However, when we talk about this auditory motor interaction or improving movements due to an auditory cue, it has to be an auditory cue because it's the auditory system that's connecting to the motor system. So that has to be cued externally. But a lot of these other types of benefits that we see could be used internally as well. Do we have time for...
For many years, people have been using music therapy for autism. Do you have scientific proof that that has an effect?
Yeah, so that's one of the a big area of the clinical work that we do at MedRhythms is with folks with autism. To keep it close to time, we do see it across motor development, cognitive development, and language acquisition. Independent even, there's a lot of people working in the social sciences of it too, so social interactions, but we see very clear evidence in movement, language, and cognition in that state. So, thank you.